you as much stuff. All right, so today is on 10-3. We have done the areas of parallelograms. We have done triangles. Yesterday was trapezoid, rhombuses, and kites. And it's all on the backboard. You're still going to need those three things that are on the left today. Not the Pythagorean theorem, but the other two, in particular, the 30, 60, 90. So you might want to take out your green, I should get closer to the board here. You might want to take out your green note card. And we won't be, like I said, the 30, 60, 90 is going to come into play on half of these today. All right, so in your notes, there's some vocabulary we've got to get going here before. And be in your note packet. What I did is I took some of the examples and blew them up because it was so small on there for you guys to write. So we'll head off to that separate sheet sometimes. But this is in your note packet. So take out your note packet and turn to 10-3. And we'll get some vocabulary out of the way first. So I'll wait for you guys to get that green packet open. Are the pages numbered? What page does this start on? Yeah, it's one more left. Oh, there it is. Page 8. All right. So we are going to be finding the area of regular polygons. We have to remember this word, which means all sides and angles. So I'll just do the angle symbol. All sides and angles are congruent. All right. So when it's not regular, actually, that's a task for higher level math. So yours are going to be regular. And we're going to be finding their areas, which this is new for everybody. You guys should have done parallelogram, triangle, and trapezoid in middle school. This is kind of the high school of it, is taking it to a higher level here. So first thing we have to do is there's going to be different pieces that you're given. You have to make sure you know what, like I'm going to say, what is the 5? And you're going to tell me, oh, it's a radius. Oh, it's an apothem, which is a weird word. Oh, it's a side length. So first of all, the radius connects the center to a vertex. So there are 6 of them on here. And there's 2 right there. I want you to write R and R. It's kind of like as if it were a circle, and it's the radius of the circle. If they give you that, you need to know, oh, they gave me the radius. Okay, so it's the distance from the center of the polygon to a vertex is the radius of the polygon. And we are going to be calling that, obviously, R. The next thing is a weird word. I call it apothem. Some people call it apothem. And I have a hard time saying apothem. I don't know what bugs me. So I call it the apothem. That is super important. So put a star by that. That's going to be, you're going to need it for every single, bless you, sweetie, every single one. You're going to need to find the apothem. It is from the vertex, I'm going to do it in black, to the middle of the opposite side, always making a right angle. So you can see we're going to be working with right triangles again. So that is going to be called an A. And there are 6 of them on here, but I like to just pull off one and work with that. All right? The other thing we're going to be working with is a side length, and that's this. So I'm going to pull off one of those triangles and just reiterate, because it's all going to be about one of the triangles. In this case, it's a hexagon, so there's 6 of them, but this would be called a radius. This would be called a radius. Again, I'm just pulling one of these out. We're going to do that for every problem. We're just going to grab one of those triangles. We're going to pull it out and blow it up. This guy, when you drop it down, is called the apothem. And this guy right here is the side length. Those 3 lengths are going to be really important for finding the area. This isn't in the formula, but if you're given it, you have to know how to get the other 2. All right, so heading on down here, we're also going to be working with what's called the central angle. Okay, so, and we've done that before. So if I were to do a pentagon, go ahead and, if you have room, you don't have a whole lot of space, so you might just want to watch. But if I were to go to the center, and if I were to draw all of the triangles made by these radii, you'll notice that there are 5 of them, right? And we said that they're all equal angular and equilateral, or they're regular. A central angle is this guy right here. he's going to be important as well. I mean, I could have put a dot in any of the 5. So remember how to get that. You're going to take the degrees in the circle. How many degrees are in a circle? You can answer me even though I'm recording. How many degrees are in a circle? 360. Yeah, and we're going to be dividing it by the number of sides. So on this one, to get that central angle in there where that dot is, you would do 360 divided by the 5 sides. So if you're looking for an angle up there, also important to know that when you drop the apothem, you cut that angle in half. All right, so that there's going to be a lot of messing around with these little triangles, which is why I blew up some of our more involved examples so that you're not working on such a tiny figure. All right, the area of an equilateral triangle is our first formula. And remember, equilateral triangles look like this. Boom, 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 same, same, same. So all of these sides are exactly the same. The formula for an equilateral triangle is 1/4 the square of a side times √3. So I'm going to rewrite that. And it's 1/4 side squared √3. So it only requires its side. This says x. I'm going to kind of get that out of there. We're going to call it a side squared. So it's really easy to use. I think you should stop right now, though, and add that. Well, let's not. We'll do it next week. We'll get our note card heaped up. So if this was equilateral and this was a 6, you would just go 1/4 times 6 squared times √3. I would show you where that formula comes from, but the notes are long enough, so just trust me. An equilateral triangle, 1/4 its side squared times √3. You might want to write that if you have room. If you have room, I'd write it a little bigger so you can find it when you're doing your homework and circle it. All right, so that's our one new formula today is for the equilateral triangle. That one's not hard to use, but the next one on this first example, we're going to stay in your note packet, but I blew it up so you could kind of see it because I thought that they made it really small in there. So you need to be able to find some angles. So this says it's a regular pentagon. And Isaiah, do you remember how many sides are on a regular pentagon? 5. N equals 5. All right, just so you know that. So that means it's made up of 5 triangles, has 5 sides that are all the same length. This one says, what's the measure of each of those angles that they're pointing at? Angle 1 is right here. It's one of the 5 that gets made when you swing around. So for angle 1, you're just going to take 360 and chop it up amongst the 5 angles in there at the center. If you did that on a calculator, you'd get 72 degrees. So I'm going to put dots in these. This one's 72, this one's 72, 72, 72, and angle 1 is also 72. All 5 of those. Okay? The next one says, what's the measure of angle 2? I'll just put angle, I'll take the M off of there. Angle 2, what they did is they drew this. Do you remember what I said this is called? What's this red line I just drew called? It's a weird word. It's an apothem. Okay? So once you drop that, you cut the central angle in half. Whether you drew it here or here, it will always cut that central angle in half. So we would take 72 degrees, cut it with the apothem, and that would be a 36 degree. And now I'm going to pull this out and make it a little bigger. So I'm going to go like this. I'm going to pull out one of the triangles. Angle 1 was this, 72 degrees. Angle 2 was this, because the apothem sliced it, and it was 36 degrees. This is 90. Angle 3 is sitting here, right there. So I'm trying to blow it up for you so you can see it. So you have to remember that the angles in a triangle add up to 180, correct? So you would go to your calculator, and to get angle 3, you're going to say, well, in the triangle is 180 degrees, and I'm talking about this triangle right here, and I'm going to subtract out the 90 in the corner, boom, the 36 at the top, and if you did that, you'd get 54 degrees. Okay, So that's just finding the angles. You're going to need them because you're going to have to know whether you're working with a 30, 60, 90 or a 45, 45. So you're going to need to be able to draw those. All right. So next up is a new formula, and I actually don't like this, so we're going to rewrite it. It says the area of a regular polygon is half of the product of the apothem and the perimeter. We are going to write a bigger version. Okay, I'm going to say it's 1/2 of the apothem times a side times the number of sides. This right here, side length times number of sides, is the perimeter. But I want you to realize you need to get 3 things. You need to get an apothem, you need to get a side length, and given for free will be the n. They'll tell you if it's a hexagon, you put in a 6, octagon, you put in an 8, decagon, you put in a 10. So you will know the n. So I want you to star the A and the S. That's going to be your task today, is figure out what's the apothem and what's the side length. Number 2, I didn't veer off onto the separate sheet because this is the kind yesterday I called easy. You have, oops, I'm going to plug in my charger. You have all the ingredients you need. So go ahead and set that up. You're going to use the formula 1/2 A times S times N. And if you're given all of them, great. Then you don't need to do any extra work. So we're going to write this down. We need to have the A. We need to have the S. We need to have the N. And I would write this down every time. Like, write down your 3 main ingredients. If you're given all of them, dump them in the formula. So my apothem is this guy. They gave it to me, 12.3 inches. My side length is this guy, and it's 8. Number of sides is always free with the word or the figure, or if it's not, you have to count them up. But a decagon has 10 sides. So on this one, it's nice because you have everything you need. So you would do 1/2 A, S, N, and you're just going to plug them in. So 1/2 times 12.3 times 8 times 10. You would go to your calculator and calculate it. But to save time today, I'm going to just trust you could work your calculator. Okay? And I think I'm going to use parentheses for multiplication just to clear up decimals versus times. Okay? So that one, you just go to your calculator, and again, we label it inches squared. Number 3 is in red, which means you're to go to that additional sheet to make a bigger space on it. So I gave a little add-on that you can stuff into your notes. I took the ones that need a lot of work and I kind of blew them up for you. So what I did with number 3 for you guys is I took one of the triangles made in here. So it's all about this triangle. And so what I want you to do is draw an arrow over to that big one I drew. We're going to pull it out and blow it up. So we're going to pull out one triangle. Go ahead and write that on there so you kind of understand what we did. All right? We're going to pull it out and we're going to find our ingredients for our formula. We need the apothem, we need a side length, and we need to know the number of sides. The number of sides is always a freebie. It's a hexagon, or I could count. So N is going to be 6 for a hexagon. The other 2, that 18 is pointing at this. It's pointing at this. Go ahead and label it. That's not the apothem. It's not the side length. It's the radius. So it can't go in my formula, and it can't go there. All right? So my problem is I need to figure out, so let's go draw it. I need to drop the apothem. I'm going to label it A. I also need to figure out down here, so you might want to bold it. I'm going to go like this. I also need to figure out this side length down here. So there's 2 things I need to figure out, which is kind of a bummer. All right? So what I'm going to do first is figure out, well, what's this angle? It's got to deal with the angles up here. I can't do Pythagorean theorem because I only know one side. So what I'm going to do is hop up here and go, well, if I had all of the triangles in here, so go to your original, we pulled out 1 of 6 triangles, right, Brandon? So what I'm going to do is, remember that if I do 360, go ahead and write that over here, divided by 6, I'll get this. And 360 divided by 6 is 60. So what I know is I've got 60, 60, 60, 60, 60 as I travel around it. All right? Also, because it's 60, right, it's actually an equilateral. But what did I do when I dropped the apothem? I cut this 60-degreeer in half. So I want you to point at that and write 30 degrees. And that's how you're going to find the missing sides. You're going to go and look at your 30, 60, 90 relationships, and you're going to ask yourself, what did they give me? They did not give me the short side, which is kind of a bummer. We like it when we get the short side, correct? So you have to look at your note card. It says that the hypotenuse, I'm going to write it right in here, is 2 times the short side. It says that on your note card, so go ahead and write it above there. So if I know the hypotenuse was twice the short side, that would make the short side 9. Correct? Also, I know the side length has to be 18. So there we go. I've got an 18 for the side length. Then I just need to figure out how I go from short to long. And on your note card, it says you do the short side times the square root of 3. And I'm going really slow on these hard ones. I put all these details on here because you're going to be doing it at home and you're going to forget. Like if you're like, oh, Sunday night, I need to finish up my math. I'm going really slow today. So it will be 9 times the square root of 3. Once you have those 3 ingredients, you're going to go put them in your formula. Your area is 1/2 A S N. Then you're going to read the directions, and if it tells you to keep it in radical form, then you'll leave root 3 in your answer, and you'll just head off on your calculator, and you'll go 1/2 times 9 times 18 times 6, root 3. If it says to round to the nearest 100, you'll just crank the whole thing out on your calculator. You might want to use 0.5 for a half, but I'm just going to put it in a box for now and trust that you can work your calculators. And when we go practice some of the, I tried to label this yard square. When we go practice, we're going to do the odds on the homework together. So on those, we'll get final answers for. All right, so we're moving right along. Number 4, I didn't put in red on mine. So that means you're back to your packet. It means there's not much work you need to do. This one I don't have a picture, but I know my formula for area is 1/2. You go ahead and write it down, A, S, N. It tells me I'm working with a pentagon. So, if it's a pentagon, Julia, which one of these do I know for sure? I know the number of sides. A pentagon has 5 sides. So you'll always get that ingredient for free. All right, so we're back in your note packet. It's right before you see some squares. I only blew up the ones that require a lot of work. This one is very easy because what does it tell me the apothem is? 8. So my apothem is 8. And what does it tell me my side length is? 11.6. So there's nothing to calculate. You're going to like those. Because all you do is go to your calculator and do 1 divided by 2, or just enter 0.5, times 8, times 11.6, times 5. So the moral of the story is you need 3 ingredients. Okay? The A, the S, and the N, but this one will be given to you always. And then I'm going to give you some shortcuts. I'm going to tell you that for the square, I would tell you don't. I'm going to have you write this on here. Use 1/2 A, S, N. You could, but if you trick them, we can avoid it. Okay? Watch. If this is a square, go ahead and mark these. All these side lengths are the same, correct? Right? And if that's 5, this is 5. So actually, if they give you the apothem, take a look. You'll know the length of the side, right? If this is 5, this is 5. This side length right here and this one right here would be 10, but it's a square. So what do you think my shortcut's going to be if you're given the apothem? What's the old way of finding the area of a square? Just do what? Area equals, go ahead and tell me, Ike. Base times height. And they're the same. So you just go 10 times 10. So that's going to be my shortcut for you. And I'll put the inches squared on there. If you're given the apothem on a square. All right? You could have, drawn your triangle, found the angles, and went and found everything. But when you were all done, you would get 100. So for that version, I would do this shortcut. And we'll get that written down on the bottom in just a second. And you should be on this sheet right now because I'm adding a little to it because that square thing is so tiny. So these are the same examples, just blown up. All right. So it says find the area of the square. Done. I'm not going to use my new formula. I don't need it. On this one, watch how I'm going to outsmart it. Okay. Would you agree, Alex, that a square is also a rhombus? What do you think? He doesn't even hear me because he's on his phone again. Can you put your phone up here? Thanks. Zach, do you believe me that a square is a rhombus? A rhombus has to have 4 equal sides. Does a square have 4 equal sides? Yeah. And yesterday we learned that to get there, so I'm going to write the word rhombus by here. Instead of me looking at this as a square, what I'm going to do is say, well, it's a rhombus. And for a rhombus from yesterday, we did a half of diagonal 1 times diagonal 2. Watch how I'm going to get the diagonals. Are you ready? The diagonals bisect each other. If that's 10, what do you think that part is, Bjorn? 10. So what's diagonal number 1?
10.
The whole thing.
Oh, 20.
20, right? Diagonals on a rhombus are congruent. So that one's also 10. So you can just do a half of 20, diagonal number 1, and then this would be 10, and this would be 10. All those radii are the same. Like if you put it in a circle, watch. If I trapped it in a circle, all of these are radiuses of the circle. They're all 10. Okay? So instead of doing it the long way, I would do a half of 20 times 20, and it's just 200. So I would shorten the squares up. We're going to write that on the bottom of our sheet, okay? So on the bottom of your sheet, we're going to fill this in, and you're going to write yourself a little note that you're going to want to get this on your note card. We're going to tuck it into your notes, and someday next week I'm going to say we need to get our note card updated. This is something I would write, because the squares are actually the hardest if you do it with the new formula. So that's, I was looking at these last night, and I'm like, why would I use this for a square? You don't need to. So when it's a square and you know the apothem, and go ahead and point over here. That was this case over here. You're just going to use what Ike said, base times height or side times side, right? They're going to be the same though. So I'm just going to write side times side. On this one, we're like, oh, 10 times 10. Done. You can almost do it in your head, right, Lauren? Watch. Do this one in your head. I'm going to draw a square. I'm going to go right here, drop this down, and I'm going to tell you that's 3. What's the side length of the square? 6, correct? So the area is just 6 times 6. We're going to take a shortcut for those. If you work with friends from other classes, you might confuse them because I think that they might be doing ASN for these. So just kind of keep it to you don't mess them up. So when it's a square and you know the radius, okay, and I'm going to go point, that's this guy up here. We're going to not use it, think of it as a square. We're going to think of it as a rhombus. And we're going to easily be able to get those diagonals. All right, so again, I'm going to draw a fake one over here. I'm going to erase all this and just show you how quick that can be if you use the shortcut. If you are told this is a square, and they give you a radius, regardless of where they give it to you. Maybe they connect it like this, and if they tell you this is 8, correct? Then this is also 8. Diagonal 1 would be 16. Diagonal 2 would be 16. And you can just easily crank it out. TK, you're nodding, right? Did the shortcuts make sense, guys? Yes? All right, good. So now we're going to go do number 6. I don't want to do this one. It has all the ingredients you need. So we're going to go to number 7. All right, and this one is in red, which means you're going to need a lot of work. So I blew it up, and I put it on this sheet right here. Okay, so you flip this one over, and we'll just tuck it in. It says the side of a regular hexagon. So first of all, I'm going to get my ingredients down. I need an apothem. I need a side length, and I need the number of sides, because I need to do 1/2. Keep it a little bit farther over here. My screen doesn't work over there. 1/2 times A times S times N. I'm going to start with the N because it's the least amount of brain power. It's a hexagon. Or I could count up the sides. It's 6. Done. That one's a free. All right, every single time. Next up, what we need to do is, you see how I blew up that big triangle for you guys? I'm going to go put mine over here. You guys, oh, actually that's right where my screen doesn't like to work. So I'm going to delete that. I'm going to put my big triangle, extend. All right, I'm going to pull one of mine. So go like this on your main figure. You need to work with one of the 6 triangles. You could draw all 6 of them, but we're going to take that one out. We're going to blow it up, and we're going to set it upright. So this triangle right here is this one right here. All right, the first thing we're going to do is go see what they gave us. All right, they had to give us some length. It gave us the side. Oh, well, thank you. That can go right in as well. So we are at down here. I'm going to go right here. They gave me a side length. They said this is 16. I could have pulled out this triangle or this one or this one or this one. They're all 16. So I'm going to go down here and put a 16 on the side length. Not a 16, a 16 on the side length. That was free. All right, I'm going to drop my apothem. I'm going to put a right angle box in there. And I know I need to find that guy. All right, everybody watch. You ready? So 360 divided by 6 is 60. This whole thing is 60. The apothem cut it and made it 30 degrees. So I'm sitting here with a 30, 60, 90. Hopefully my voice has been in your head going, you need the short side. This is easy to get the short side out of, because watch. If the whole length is 16, what do you think? Then go ahead and bold this, because this is kind of what you need. If the whole length is 16, what do you think this short side is? What's your guess line? The whole length is 16. What's the short side? 8. And you might say, why do I need that? Because to get the long side, you need to do the short times the square root of 3. You'll never need these. You'll never be doubling your short. I'm going to repeat that. You'll never be doubling the short, right? Never. So the radius isn't in our formula. So if you're like, I don't know if I should double or multiply by root 3, don't double it. Okay, that would give you this guy over here. So now I can go up here and put in 8 root 3 in. And then I go plug them into my formula, 1/2 the apothem times the side length times the number of sides. And this last one I'm going to do, and I'm going to do it in simplest radical form, which means I'm going to leave the root 3 in my answer and just do the rest on my calculator. So could you take your calculator, Bjorn, and do 0.5 or 1/2 times 8, or in your head just think, oh, it's 4 times 16 times 6. If it says simplest radical form, you just write the root or radical down and go to your calculator and crank out the rest. What is it?
384.
So let's do this. 384. And it was square feet. And if it said to the nearest tenth, then you would put the root 3 in on your calculator. How's that? All right, last up. The triangles. All right. You might say, you gave us a formula for the triangle at the beginning, Rude. I did, but it had to be equilateral. So these, you do need your A, your S, and your N. Let's write that down for all of these. I need my A, I need my S, I need my N. And on this guy, I'm going to need my A, I'm going to need my S, and I'm going to need my N. Zach, you've been listening. Which variable am I going to fill in on all of them right now? The A, the S, or the N? N. I'm going to go 3 because it's a triangle, 3 because it's a triangle, 1, 2, 3, 4, 5, 6 because it's a hexagon. That's done. Okay. Next up, I need a side length and an apothem. This is a radius. That's a bummer, correct? Because it's going to a vertex. I'm going to draw this. That's also a radius. That's also a radius. That 2 does not go in here. Okay? I'm going to go to the next one, and I'm going to draw the triangles formed. That 7 actually gets to go in here. Which one is it? This 7 right here. What is it? A. So I'm going to go right there. I just want you to realize what you're looking for and what you're given. Over here, if I went and drew the triangle, they didn't give me the radius, but again, they dropped that down. They gave me the apothem. So that's what's free on all of them. Are you good with that, Mina? I just wrote down my free stuff. Now, this is going to be the hardest because I have 2 things to find. Okay, so what I need to do is go up here and work and drop my apothem down. So I'm actually going to go over on this one. This is a 2. I don't like to work. I like to work on the one facing me. And this is a 2. Go ahead and put it on there. I like to work with this one, and I purposely gave you extra because I want you to pull it out and draw it nice and big up at the top. So we're pulling this one triangle out right here. It's got a 2 here and a 2 here, which is not the least bit helpful because R isn't in my formula. I'm going to drop the apothem. I'm going to put it even up a little bit higher. Let's put it right there. I need that, and I need that. All right, Adam. Well, I picked on you already. Eve. It's all about the angle measures. 360 divided by what to get one of these peaks? 3. So I'm going to over here write 360 divided by 3. That's 120. Okay. But Logan, once I drop the apothem, I cut that in half, correct? So this guy's a 60. This guy's a 30. Lots of 30, 60s. Now you have to ask yourself, what side do I have? And what side do I need? All right, so this is the hypotenuse. It's twice the short side. You need the short side. Tessa K, if 2 is twice the short side, what's the short side? 1. That's this one. Great. Boom. Right? Now the tricky part. Look at your note card for your 30, 60, 90. How do you go from short to long? What number do you multiply by? It's a weird number. To go from short to long, what do I multiply the short by? Go ahead and tell me. Anybody? Root 3. Exactly. This is tricky. Okay? There's lots of messing around with 30, 60s. So now my side length isn't root 3. It's root 3 plus another root 3. And then you throw them into your formula. I'm not going to write the formula. I want to save some time. I want to get to the odds so we can do some of those together. On this guy, all right, I actually have the short side. So that means this is 7 times the square root of 3, which means so is this over here, which means the whole side is 14 times the square root of 3. That one was nice. They gave me the short piece of cake. And the last one up. Are you ready? So on this guy over here, I'm going to blow that triangle up again. So I'm going to grab this one triangle and blow it up nice and big. And you guys aren't listening well for, I know this is a long lesson, I'm sorry. And it falls on a fake Friday. All right, so when they drop this down, this was a 4 root 3. Okay, that is the apothem, so that's great. But I need to go back and get the side length. What do you think I'm going to do? The long side is the short times the square root of 3. So what do you think this short was? The long side is short times the square root of 3. What do you think the short side was? What do you think, Julia? 4. Excellent. And then be very careful that you don't put a 4 right here. You found this little piece right here, so that becomes an 8. And then for all of these, you just go 1/2 ASN on your calculator. All right, that's the end of the notes. We're going to go to the worksheet, and because this is a hard lesson, we are going to do odds together, so you guys are going to have to help me with your calculators, because I don't have one, okay? I'm going to let you skip that. I think we know how to find the angles, so go ahead and cross those off. If when you're listening so well, I let you skip stuff. At the top, I want you to write 1/2 ASN. For the squares, we won't use that. We'll use our 2 shortcuts. So if it's not a square, you need the A, the S, the N. So we're going to start with the odds, and then your assignment is going to be the evens. We're going to go to number 5, and we're going to ask ourselves, do we know the A? Yes. Do we know the S? Yes. Do we know the N? Yes. So everything was given for free, so you're going to take out, write down. We need to, the area is 1/2 A, S, and a hexagon has 6 sides. Somebody go to their calculator quick for me, and I need 2 people to agree. If you want to use 0.5 for a half, go ahead. But now we'll crank them through. So go ahead and crank that out on your calculators. They gave me everything I needed. They gave me the A, they gave me a side length, and they gave me the numbers of sides. That's best case scenario. And then I'll take, some people are doing it for me right now. Parker, do you have it done? You're faster than your calculator. 508.2. I have some nods over there, so good. 508.2, and I label this feet squared. All right, I liked that first one. I like number 7 as well. Right, Logan K? Because again, I just do 1/2 A, S. Now we have to go back to another chapter. Do you guys remember how many sides are on a nonagon? 9. Yes. So if you don't know those, you might need to add those on your note card. I don't think it's going to go past, it might go to a dodecagon. It might go to a 12-sided. But yeah, octagon is 8, nonagon is 9. So that's going to go right here. You guys are going to crank it through on your calculator for me. And did you run it through? Yeah? Nope, not yet. Parker, you're fast. I'll take yours and then see if somebody can back you up on it. What'd you get? 8,475. Anyone else run it through there? Yep, Adam's nodding. 8.5, and that would be meters squared. Done. Okay? Now, there's a very important word on this one. Regular. Okay? We're actually going to do an even on this one because this has its own formula. I want you to write, this is a side length. Remember, if it's a regular or equilateral triangle, you just do √3 and then times the side squared. So that's like, don't worry about that one, that's easy. It's from the very first page of your notes. We're going to go to number 8, and we're going to say we need the apothem, we need a side length, we need a number of sides. It's a hexagon again. And actually, they gave me one of these other 2. Right, Bjorn? Right, Katie? This right here is a side length. That's 12. This is 12. This is 12. And this is the one I like to work with. I like to work with the one in my face. So I'm going to just kind of work with this guy right here. Okay? They gave me this. Sweet! All right? If you want, look over here. I don't know if you guys have enough room, but I'm going to pull this guy out just so you can see it a little bigger. This is 12. When I drop the apothem, I cut it in half. So I've got a short side of 6. Correct? I need the long side. Everybody go to your note card. Are you ready from yesterday, Preston? How does it say you get the long side when you've got the short side on a 30, 60, 90? I need to go from short to long, and on your note card, it should say what? Root 3. And what did I tell you? Never double it. That gets you the radius, and that's not in your formula. So when in doubt, this would be 6 root 3. So again, I'm going to need some calculator help because I'm going to erase my helper triangle right here. And you might want to keep it like a scratch paper and so you can blow those triangles up. They don't give enough room on here. I don't write the worksheets or the notes actually. 1/2, and then I have to do A, and then I have to do S, and then I have to do N. If you want to use a 0.5, go ahead. This one does say to round to the nearest tenth. So here's my 1/2, A, which I found, S, which was given, N, which was given. Run it through your calculator for me, Parker, and we'll see if we've got a backer. 374.12. I got to get an agreement on that. You got it? Awesome. 371.2, he said, and that would be inches squared. All right, moving on. We are going to go to number 11. It's the angle stuff again. So I'm going to are you okay with how to find the angles? Right? If you have a hexagon, let's just go do number 11. All right, if you have a hexagon, and you go ahead and draw one of the 6 triangles, or all 6, whatever you want, and it asks you for the angle formed, and then it says by 2 consecutive radii. They're asking you for this, or this, or this, or this, or this, or this, right? So what am I going to do on my calculator? 360 divided by 6, all right? And 360 divided by 6 is just 60 degrees. Are we good with that? All right, let's go to the next page and let's get to a hard one. Let's go do number 15. Okay? For all of these, I want you to see you going A, and I want to see you going S, and I want to see you going N. Some of you might like to have a scratch paper where you actually pull off a big version of the triangle. I'm going to do it over here. You can't because you're going to need, they didn't give you a whole lot of room, but I'm going to pull that one out and just work with it. It looks like they dropped the Apothem for me and labeled it 5.5 root 3. So they gave me a free here. And the number of side lengths, it's a hexagon again, so 6. Oops, I put it in the wrong spot. It's the Apothem. 5.5 times the square root of 3. Good? Am I going too fast, Tessa, or am I good? I'm good? All right, so I don't care about the radii. Don't care about that. I care about the side length, so somehow I have to go back to the short side. So if I multiply by root 3 to get the long side, what was the short? What do you think, Logan, in the back? What would this little piece right here be? 5.5. Yeah, because the long is multiplied by root 3. So this must have been a 5.5. I don't put that in for the side length because I actually found on my big picture, I found only half of it. So if that's 5.5, and this is 5, you guys are really listening. I'm recording, so I know you have to be quiet, but there's my ingredients. This one says simplest radical form. Okay, so we're going to do 1/2 A, S, N, and I told you guys for simplest radical form, you're going to cross this off, put it in your answer, and then hop on your calculators to do 0.5 times 5.5 times 11 times 6. You multiply everything but the radical. Sorry, Parker, but you're my fast calculator. You already have it done. Thank you. What is it? 181.5. And we kept the square root in our answer. Okay? One last one together because you're not going to do these. They're from a section we skipped last chapter. So you don't need to do those. We are going to go do the soccer ball. Okay? So if you had a soccer ball, when they make it out of the leather fabric, they stitch together 12 regular pentagons and 20 hexagons. If you ever looked at a soccer ball, you'll see that. Do any of you play soccer? Do any soccer players in here? Aren't you one? No, you're tennis. But they stitch together pentagons and hexagons. Let's see what information they gave me. So I'm going to have you write pentagon over here, hexagon over here. It asks you the surface area, which would be the amount of leather needed to make the ball. All right? For the pentagons, we need this ingredient. Pentagons have 5 sides, so that's good. Let's see what it tells me about the pentagon. Both polygons have a side length of 3. Well, they have to so that they can stitch up, right? And it says the pentagons have an apothem of 2.06. So for my pentagon, they gave me everything I need. Okay, so let's go deal with those first. We're going to take out our calculator. For the pentagons, we're going to do 1/2 A, and Parker, I'll have you do that for me, S, N. They handed me everything for the pentagon. Multiply that out. This one's kind of a lot of work, so you can be glad I did. What did you get, Parker? All right, you got 15.45. That's 1 pentagon that they're going to stitch. How many did it say they're going to be stitching on there? I'm not looking at it, so you got to read it. How many pentagons are there? 20. Awesome, you guys are listening. So Parker, I'm going to have you do 20 times this. It'll tell me the fabric needed for the pentagon. Not fabric, they're made out of like leather, right? It's 12 pentagons. Oh, it's 20 hexagons. Thank you. So it's 12 pentagons. So Parker, can you multiply that by 12 for me too? 185? Point what? And it says to the nearest numbers, whole number. So let's just do 185. All right, we just took care of stitching the 12 regular pentagons. We also have 20 hexagons. So I need this, I need this, I need this. Hexagons has 6 sides. They told me the side length is 3. I'm searching to see if they told me what the apothem is because you're my first hour. And I go, oh crap, they didn't. Correct? So a hexagon, what you're going to do is you're going to pull out one of the 6 triangles made. Correct? You're going to drop the apothem down. This was 3. I told you I had a side length of 3. I mean, I could have drawn the whole hexagon here, but we really only need the 1 triangle. So that means this was 1.5. The side length is 3. They told me that. So last up, everyone's listening to this. I love this class. Gabby, how do you go from the short side to the long side? Yes. No, she didn't say to multiply by 2. You'll never need the radius. So she's going to do 1.5 times the square root of 3. So last up before you leave, I need Parker to run this through his calculator for me. We have 20, so Parker enter 20. And we have 1/2 A, right? 1.5 over 3. S is a 3, and N is a 6. I did a lot of them with you today. It's a hard lesson. I have no clue what that is, but I'll take it. It's 20 of the 1/2 A, S, N's. This is a 3, and that's a 6. All right, and then you add them up and you're done. What's your assignment? Just the evens that are left. I did half of it for you and had you cross off for it. All right, good job today, guys. It's a long lesson. But I think you got it. If you want to do my elk time, it's for work time. I'm not sure if there's any spaces yet, but if you just want to kill this off during my elk time, feel free. Kylie, I signed you up for mine to take your test.